Now, so that happened. So f of 0, so f of 1, we're going to use f of 1, right, because it's centered at 1. There's going to be ln of 1, which I believe is 0. Yes, sir? Yes, sir. Okay, f prime of x would be 1 over x, which means it would be f prime of 1 would just be 1, which is 1. I don't know why I'm making 2 columns for that. That's kind of awkward. So far, so good? Am I doing this wrong? You look like I'm doing this wrong. Taking the derivative? Okay. F double prime of x. Oh, I'm going to write this as x to the negative 1 so I can do math easier. Negative x to the negative 2, right? So if I put in my thing of 1, I'm going to get negative 1. Right?
It should be double.
Double prime. Thank you.
On all these exponents, because you center around.
Well, watch the next one. See the next one? Well, then I'm going to get 2x to the negative 3. So this is going to be what? 2, right? The x part's going to be 1, but the... Make sense? Marcin, okay? Move your face a little. You good?
Yes.
Okay. You can't tell from the look on your face. All right, we'll move forward. Okay, so I'm going to set this up. I need a series. Did I limit how many? Oh, we wanted to figure out the nth term, right? Because we're finding the interval convergence. Got it. So I'm going to go ahead and go ln of x is equal to 0 plus 1x plus, not plus, minus.
Aren't all these x minus 1?
X, oh, yeah. Yes. Is that, you're here. You're asking this question.
Well, even the ones in those.
No, I'm still taking the derivative like normal. I'm plugging in 1 instead of plugging in 0. That's the difference. That was your question? Sorry, I was missing. That's why we were looking at each other, because I didn't yet understand your question. Now, it happens over here, right? We're going to shift over here. We're taking the derivative at 1. So this is f prime of 1. Right? And then this next one becomes f prime at, which is x minus 1 squared over 2 factorial, plus, and the next one is going to be 2, x minus 1 to the third over 3 factorial. And with a little bit of reasoning, I realize I'm going to throw the 3 out in front, so the next one's going to be 6, negative 6, x minus 1 to the fourth over 4 factorial. Why am I minusing 1? Oh, sorry, you're right. Are you good there? Okay, so with a little bit of thought, I realized that this is 2 factorial divided by 3 factorial, that's just a 3. This is a 3 factorial divided by 4 factorial, so that's just a 4. So that's probably the pattern. So my ln of x series is going to look like x minus 1 to the first power minus x minus 1 to the second over 2 plus x minus 1 to the third over 3. I wrote a factorial as if it's factorial, but it's not. Fix that. Minus x minus 1 to the fourth over 4 plus dot, dot, dot. Is that okay, Miss Lasagna? Okay, is that okay, Miss Jean Greco? Smith, my other holdout for sureness is not here. All right, Welko, you have to take the job. Welko, good?
Yep.
All right. Okay, so that's my series. So I'm going to figure out what I want to figure out the interval convergence for this series. So what am I going to do? Ms. Lasagna. We're going to try to find the radius. We're going to use the ratio test to find convergence, right? We're always going to start with ratio test. Oh, if there's a convergence question, I'm starting with the ratio test. I got to find my nth term. So what's my nth term going to look like? That? Can you use words like involve x's in parentheses and cred? What's the nth term? Come on, really, we got to cover some ground today. This ain't it. The first term has 1 power, the second one has 2, the third one has 3, the fourth one has 4. So this is going to be x minus 1 to the nth power over, well, this is a 2. It's a 1 in the first one. It's a 2 in the second one. It's a 3. So it's just an n, right? You really have to be able to do that much. Okay, we have an alternating -1, so I throw a -1. Is your preference n plus 1 or n minus 1? It don't matter, just pick one. N minus 1, that's what we're doing this year. That's interesting. I don't remember ever doing -1 as the preference. Okay, so next term would be -1 to the n, x minus 1 to the n plus 1, all over n plus 1. Agreed? All right, how do I do the ratio test? All right, R equals, I've got -1 to the x minus 1 to the n plus 1, all over n plus 1, times, flip, n on top, -1, x minus 1 to the nth. Agreed? Oh, I dropped my -1, sorry. -1 to the n, and -1 to the n minus 1. Thank you, sir. All right, so I got one more n on top than bottom. I got one more -1 on top than bottom, so I put a -1 there. I've got one more x minus 1 on top than bottom. N plus 1, n. So I get an x minus 1 on top. I have an n on top and an n plus 1 on the bottom. Anything else I need to worry about? Okay. Now to perform the ratio test. G and Greco, what's the next step? Take the limit as n approaches infinity. It's key you get the right letter, right? Because sometimes I'm going to have an n, so it confuses you, like I'm making x equals there. You can't do that. Okay, I'm going to lift this thing up because otherwise we're going to run out of space. What? All right. So now I'm going to take the limit as n approaches infinity of, this first part is -x plus 1, right? And then I've got that times n over n plus 1. Now here's something interesting. Is x have any part in n? No, it's a set number. We just don't know what it is, right? So our classic definition of a variable. So therefore, the only thing I have to take the limit as n approaches infinity is the n over n plus 1. And what is that going to be? Okay, so then what we'd have to do? It's going to be 1, right? Hopefully at some point you start to go ripping through these, right? Like this is going to be 1, right? So this is going to be -x plus 1 as our limit as we approach infinity. So where is this thing convergent? We're going to make Mr. Larson do this because yesterday he couldn't do algebra 1. -1 plus 1, absolute value less than 1. What do you got for me?
Well, you have your fancy method, but I just look at it.
And what do you get looking at it?
Either so 2 is one of them.
2 is one of them. Okay, so listen to me. Listen to me. Here is the calculus cheater way, not the algebra 1, which was so hard to do. Here's what you do. It's a radius inversion, right? What's this thing centered around?
0. Oh, 1.
Centered around 1. Centered around 1, and one of your answers is 2. The other one's going to be 0. Make sense? Okay, so one of the things you can do is just remove this, solve it, right? Ignore the absolute value bar, solve it, and then goes up the same amount as it's down. Frankly, that's why the radius convergence exists, because people that can't do it the other way. So 0 to 2 is our interval of convergence. Yes, sir? We haven't tested the points yet, have we? We got to check 0 and 2. It's a place we don't know. Yes, sir?
Going back to the limit.
Uh-huh.
Couldn't you distribute the n to the x part?
You could if you wanted to. You just have to take it back out. If you divide n over n, it just goes away. You're taking derivative with respect to n, so x is ignored. So it's equivalent to, this doesn't matter in the limit, so I can throw it out in front.
But you're allowed to keep it in there.
You're allowed to. It doesn't make any difference.
But I had a difference.
How'd you get a difference?
So if you distribute the n and it's negative
n
plus n.
nx plus n over n plus 1. You're going to divide by the highest part of n you find anywhere in the problem.
Yeah.
Right? So it's going to come right back out. Or you could, use calculus. The tricky part about using the L'Hopital's rule is you have to recognize that x is not what you're taking derivative of. So it would lead to a chain. It's the change in x with respect to change in n. And x is not changing because x is going to be some number that we're checking out in this particular context. Okay, so 0 and 2. I need to pick. How do I figure out what it is at 0? I'm going to plug in 0 into my thing I made. There's my thing, right? So the first term, if I plug it in, would be negative 1 to the nth times negative 1 to the n minus 1, which is always going to give me negative 1. That's really confusing. My head hurts. Okay, so I'm gonna start doing this series, right? What was the series begin with? It was negative 1. Holy mackerel! I want to go back to the top. Well, what did the top say? X minus 1. Then what was it?
Minus x minus 1 squared.
It's minus 1 squared over 2. There we go. This is going to be easier than going back and using the formula, right? Okay, so I got to figure out what this is convergent or divergent when I plug in 0. When I plug in 0, this becomes negative 1. This becomes negative 1/2. Is that right? 0, negative 1/3. Negative 1/4. Is that right?
Yes.
Okay. Is one of them positive? They should be. I think they should be alternating positive. Hold on. Let me put a 1 back in here. Let's put a 0 back here. 0, negative 1 squared positive. There's a minus out in front, so no, it's negative. They're all negative. So since they're all negative, why?
When you multiply that by negative 1, you see the harmonic series.
Yeah, the harmonic series is divergent. Because it's all negative. It's not an alternating series. What? I was trying to plug in 0 here and then do each of the terms. That's a headache. I had it written out like this, up or above, right? It's much easier to plug a 0 into this than plug a 0 into this, and then then plug a 1 up here and then do a 2 in. Sometimes it's easier to do this one. This one's not one of those cases. Okay, so it's divergent, so I keep that as a curved bracket. Now I'm going to put a 2 in there. If I put a 2 in there, I get 1 minus, put a 2 in there, I get 1/2. Plus, put a 2 in there, 1/3 minus 1/4 plus ... Convergent or divergent? Convergent. Why?
Alternating series test.
Alternating series test. Each term is smaller than the previous one. And if you write this series as 1 over n, which is what it is, that is going to go to the limit as n approaches infinity is 0. Passes both tests. That's convergent, so we end up with a square bracket here. That's just about everything in this chapter with a bow on top. The only thing we have left is error. Okay, so let's go ahead and tackle the first problem. Now, this is everything. This is starting from log natural, finding my integral of convergence, right? So on your homework, the first problem on your homework, was the only one problem I actually do, it said, what did it say?
Find each interval and radius of convergence.
Right, I had, oh yeah. So I'm going to find each interval of convergence and each radius of convergence. By the way, the radius of convergence for this would be what? Larson? 1, right, because it goes up and down 1. Okay, I'm going to pause this. Say